Hello, hello, dear students. Welcome back to my YouTube channel. I hope all you are doing great. I guess I'm audible and visible to all of you. Am I audible and visible? Yes. Okay. So today we will be discussing lecture number second of EM waves, or it is last lecture of EM waves. From tomorrow or day after tomorrow, we will be starting modern physics. So I guess my screen is very well visible to you, right? Hello, beta. I just changed the software of writing now. So today I'm just writing on the new one. I hope you like this one now. First of all, I need to see whether this screen is visible. 1 second. Okay. Okay. So my new screen is very well visible to you. So let us start. Lecture number, as you can see now, we will be discussing lecture number second. Lecture number second of EM waves. First of all, we will be discussing this numerical from NCERT. This one is from my NCERT. Done. And the numerical is like 1 second. You can see the numerical. 1 second. Okay. Look now. A parallel plate. 1 second. 1 second. 1 second. I hope that it was a highlighter, no? No, no. I don't need this one now. Okay. So as you can see now, a parallel plate capacitor. This one is my parallel plate capacitor. Made of circular plates such of radius. Radius is given 8 centimeter. So if I can just make this one now. So this radius is given to me. It is 6 centimeter. It is 6 centimeter, or I can write 6 into 10 to power minus 2 meter. Okay. Look now. Has a capacitance. So C there is capacitance is also given as it is 100 picofarad. It is 100 picofarad. You can see now. Is it given to us? Yes. 100 pico means minus 12 farad. Then the capacitor is connected to a 320 volt AC supply. That means my VRMS is given as it is 230 volt. Done. With angular frequency 300 radian per second. That is omega. It is 300 radian per second. Done. What is the RMS value of conduction current? So what we have to find out, sir, we need to find out the conduction current. Conduction current. Okay. I guess we can use Ohm's law, that is V equals to IR. V equals to IR, that is VRMS, IRMS, IRMS, XC. VRMS is 230. IRMS, I need to calculate IRMS. XC is 1 divided by omega times C. So IRMS is equals to 230 omega. Omega is how much? It is 300. C is, it is 100, 10 to power minus 12. So look, 2 to 4, 4 1 5. So I can write 23 into 3, 10 to power minus 12 plus 5. I can write like this now. 3 3 are 9, 3 to the 6. It is 6.9. It is minus 12 plus 5. Minus 7. It is not point. We don't have point here, no? So I can write here 9, 3 to the 6. 69, 10 to power minus 7. Or I can write 6.9, 10 to power minus 6. Or I can write IRMS equals to 6.9 microampere. Microampere. Is this visible? Very easy. Simple, easy, no? This one is done. Second point, is the conduction current equal to displacement current? Yes, we know it now, that IC equals to ID. We know it. Yes. Determine the amplitude of B. Amplitude of B means B naught at a point 3 centimeter from the axis between the plates. It simply indicates it is here, 3 centimeter now, somewhere here, right? 3 cm. So the radius, this one is given as 3 centimeter. Done. So first of all, we will derive the whole thing. Then I will show you the shortcut way to deal with it. Look now. What is E now? E, sir, E equals to sigma by epsilon naught. We know it for a capacitor, and sigma it is Q by A epsilon naught. Done. Q, area through which the flux is crossing. It will be only this area. And this area is pi, or electric field. It will be the big one. It is pi. Let's suppose this one is R, capital R. I can write pi R square multiplied by epsilon naught. Done. What is flux now? Flux. Is it E times A? What is E? E is Q divided by pi R square epsilon naught area. Area through which the flux is going. It will be only this area. That is pi R square. Pi to pi cancel out. So my answer came out to be Q R square whole divided by capital R square epsilon naught. Done. So now let us use the formula. Integration of B dot dl equals to nu naught I. IC plus ID. Here IC is 0, it is inside. What is B? B is constant, I can write B. dl, it will be 2 pi small r. Nu naught I. Nu naught I. So, but we have one more formula, that is, it is epsilon naught d phi E by dt. So here I can write now. Okay, here I can write one more. I will write here one more thing, right? So my it will came out to be B multiplied by 2 pi r nu naught epsilon naught d divided by dt, and phi will be q r square whole divided by r square epsilon naught. So I can write B 2 pi r nu naught epsilon naught. I will take r square outside whole divided by r square epsilon naught. So my equation is dq by dt. 1r cancel out. So my B came out to be nu naught epsilon naught cancel out now. epsilon naught also cancel out. It will be nu naught. Epsilon naught is not there. It would be not there. So why then I'm writing this thing right? 1 second. Nu naught. Then we are having r whole divided by, it will be 2 pi r square into I. What is I? Because dq by dt is I. dq by dt is I. 1 second. Then nu naught I r 2 pi r square. So if you are very good now, if you are very good, so one thing that I will just tell you, look now. So this equation, this one now, this equation is because of, you can simply use magnetic field inside solid cylinder. If you know that if this is my solid cylinder, inside magnetic field is nu naught I r whole divided by 2 pi r square. Done. So now my 1 second, I can write B now. B nu naught is 4 pi 10 to power minus 7 r. What is r? R is 3 centimeters. I can write 3 10 to power minus 2 I. What is I? Is there any current now? 6.9. So is it 6.9 10 to power minus 6 whole divided by 2 pi. I can write 2 pi r. What is r? R is 6 10 to power minus 2 6 10 to minus 2. It is square now. 1s are 2 2s are 4. So we are having this 2 cancel out. Then 6. So we are having 3 2s are 6. 3 2s are 6. 1 6 1 6 cancel out. So we are having 6.9 10 to power minus 13 plus 2 whole divided by 6. Okay. So it will be 1.01, let us suppose, 10 to power minus 11. 10 power minus 11. You can do it now. Done. Easy. This is how you will deal with it. Easy. I guess this screen also is very good now. I am able to write each and everything on the screen. Easy. Easy, no? A very good numerical, you can do it. Now second numerical. Oh, let us just complete one topic, then we'll start one more numerical. Okay, let us just start one more topic, then we will start one more numerical. Okay, 1 second now. One second. Okay. So now let us start topic known as electric field and energy density. So my topic is energy density. Energy density. Done. Energy density. Okay. Look now. If we talk about electric field, if we talk about electric field, so the electric field energy density, we know that 1 by 2 epsilon naught E naught square, or you have heard about E square. There is no issue. I can write here E square also. E naught E square. E square. E square. Okay. And the unit is, it is energy density. Energy density means it is joule per meter cube. And one more thing, that E equals to E naught sine omega t minus kx. Place the value now. So my energy density came out to be 1 by 2 epsilon naught. Then I can write it is E naught square. Then I will have sine square kx minus omega t, or omega t minus kx. So here I have omega t minus kx. One second. So I can write here omega t minus kx. So I can write energy density is 1 by 2 epsilon naught E naught square multiplied by 1 by 2, which came out to be 1 by 4 times epsilon naught E naught square. 1 by 4 times. So now I need to take this thing into my value. So this one, just remember this equation now. Okay. Now, one more thing, that is, so this was all about the electric field. What about the magnetic one? So I can write here magnetic also. Magnetic field. Magnetic field. Magnetic field is like, it will be 1 by 2 B square by nu naught, and B is equals to B naught sine omega t minus kx. So I can write here 1 by 2 B naught square sine square omega t minus kx whole divided by nu naught. So it came out to be ud, it will be equals to 1 by 4 B naught square divided by nu naught. B naught square divided by nu naught. This one more equation. So left side equation first, right side equation second. Equation first is energy density. Left side is energy density in form of electric field. Right side is energy density in my magnetic field. Done. But it is all about energy density. It is all about energy density. Now let us talk about average value of energy density. Average. Okay. How so? Look, if we are talking about densities, so this is my density, this is my density. But why I have filled here 1 by 2, this 1 by 2, this 1 by 2? Why I place here 1 by 2? Why I place here this value is 1 by 2? Because 1 by 2 is the average value. 1 by 2 is average value of sine square something, sine square theta. Here also 1 by 2 is average value of sine square theta. Done. So by this equation, we conclude that average energy density, the most appropriate way to represent would be, it would be, look, it is energy in magnetic, in electric field equals to 1 by 4 epsilon naught E naught square energy density. The average one in magnetic field is 1 by 4 B naught square upon nu naught. These are two equations that you need to remember. These are two equations that you need to remember. Easy or super easy? Easy, no? Now, if you need to find out relation between average energy density of electric field and magnetic field. How to write it? How to write it? How to derive it? How to write it and how to derive it? Look now. For electric field, we know that it equals to 1 by 4 epsilon naught E naught square. We know it very well. And what is speed of light? Is it E naught by B naught? What is C? Is it 1 divided by under root of nu naught epsilon naught? So here I can write it equals to 1 by 4 epsilon naught E naught. E naught will be C square B naught square. I can write 1 by 4 epsilon naught E square will means 1 divided by epsilon naught, sorry, nu naught epsilon naught, then B naught square. This one cancel out. So I can write average energy density in electric field equals to 1 by 4 B naught square divided by nu naught. I guess if you can check this one, no? This one, if you can check this one is average energy density. This one is average energy density in my magnetic field. So therefore, average energy density in electric field, it is equals to average energy density is magnetic field. Done? So what will be total? So total energy density, average, no? It will be equals to average energy density of electric field plus average energy density of magnetic field. Both are equal, so I can write it is 2 times average energy density of 1 or second one. 2 multiplied by 1 by 4 epsilon naught E naught square, which is equals to 1 by 2 epsilon naught E naught square. This thing. So these are some pointers that you need to keep into your mind. These are some points that you need to keep in your mind. These are very easy, but still you need to keep this thing in your mind. Okay? Easy or super easy? You will get all these notes, no? So just pay attention to all the classes. Don't write everything. I am, if you can check my Telegram, I uploaded these notes, no, in earlier times. Don't need to write each and everything. Pay attention only, right? Enjoy like a movie. So this was all about electric field energy density and magnetic field average energy density, relation between them and the total energy densities. Look, you can see now this chapter is ultimately related with the previous two chapters, previous three one. Now, if you understood each and everything, let us do this numerical now. So what is given to us? What is given to us and what do we have to find out? Look here. the ratio of average electrical energy density, average, it will be 1 by 4 epsilon naught E naught square. To the total average energy density, it will be 1 by 2 epsilon naught E naught square. It is ratio. I guess, look, if you take ratio, it is 1 by 4 epsilon naught E naught square divided by 1 by 2 epsilon naught E naught square. Cancel out 1, 2. So my answer is 1 by 2. My answer is 1 by 2. Done? Option number 4. Option number 4 is correct one. Super easy. Super easy. Easy now? Next one now. Okay. Next numerical is for a plane electromagnetic wave, it is E equals to E naught sine omega t minus kx, and B is like this. The ratio of average electrical energy density to average magnetic electrical density. Look, what is this one now? Sir, I guess both are equal. Okay, so it states that average energy density of electric field to ratio of average electrical energy of my magnetic field. Average, no? So I guess it came out to be 1 by 1 only. We just done it, no? Right, sir? If we can go previously, no? Look, both are equal. Both are equal here. You can see here by this equation, both are equal to each other. Average energy density of electric field equals to average energy density of magnetic field. If both are equal, that simply indicates that it equals to 1:1. Now this numerical was asked in JEE Mains 2024, the latest one. What is given to us? In a plane EM wave, the electrical field oscillates sinusoidally at a frequency, or frequency is given, that means F is given. F is given 5 10 to power 10 hertz. Done. And an amplitude of volt per meter. That means E is given to us. If it is amplitude, amplitude means the peak value. E naught is 50 volt per meter. The total average energy density, okay, of electromagnetic field of the wave is, okay. So what we have to find out? We need to find out total. What is U total now? What is U total now? I guess you know it. Yes, sir. 1 by 2 epsilon naught E naught square. Done? Okay. So 1 by 2. What is E naught? Here it is given. It is 8.85 10 to power minus 12. E naught is 50. I can write 50 multiplied by 50. Done? 50 into 50, 2500. I can write 2500 10 to power 2 minus 12 multiplied by 8.85 divided by 2. So I can write 2 on the 2, 2 4s are 8, 2 4s are 8, 2 2s are 4, like this. So it will be 25 multiplied by 4.4 10 to power minus 10. So if it is 100, so it will be 1.08 or something like that, 10 to power minus 8. Done? Minus 8. Minus 8. Minus 8 means it is 1 point. Now look, minus 8 but 2. Wrong. 4 minus 8. Wrong. 2. Wrong. Option number A. 1.106. 10 to power minus 8. Joule per meter cube. Easy or super easy? I am showing you each and everything, my beta. Okay. Now new things. I can do one thing. I can just add here slides. Look now. Now let us start intensity part. Let us start intensity part now. Let us change the color now. Hope it will be a good one now. Intensity now. Intensity. What is intensity? What is intensity? Intensity is equals to energy per unit time per unit area. Intensity is what? It is energy per unit time per unit area. Energy we can measure it joules. Time in seconds. Area in meter square. Area meter square. Joules per second means watt per meter square. Per meter square. Let us suppose we are having something like this. Suppose we are having some part like this. Okay. Area of cross section is A. Area of cross section is A. It is area of cross section. Light is entering through this section, as all we know that, and light will leave. And light will leave. Do you know one formula that speed equals to distance per unit time? So what will be distance? What will be distance now? Is it speed multiplied by time? What is speed of light? Is it c? It is delta t. So I can write this length will be c delta t. This length of this part, c delta t. It will be c delta t. Done? C delta t. Look now. What is energy density? What is energy density? Energy density is energy per unit volume. Therefore, what is energy from this formula? Energy means energy density multiplied with the volume. Multiplied with the volume. Done? Now right here, what is intensity now? Intensity is energy per unit time area. Now can I write here? Energy means energy density. Is it energy density? Then volume whole divided by area multiplied by time. What is energy density? Is it 1 by 2 epsilon naught E square or E naught square or E square? Okay. What is volume? Volume is area into length. What is length? It is C delta T. Whole divided by area. Area is A and time is delta T. You can see now A cancel out. Delta T cancel out. So therefore, I can write intensity. Came out to be 1 by 2 epsilon naught E naught square multiplied with the C. So this is my intensity formula, and that you need to remember. Simple. You need to multiply energy density with the C. You will get what? Intensity. Easy. And I am deriving each and every formula. I hope that you can get it now. I am deriving each and everything. You cannot tell me that no, sir, you are not deriving. No, I am deriving each and everything. Then easy or super easy? Easy or super easy? What happens to my network once again? Super easy, no? I am deriving. I am deriving each and everything. And I like this one, this board. No? On this board, I am freely to write each and everything. Right? Okay. Now, if this thing is very clear to you, let me show you a numerical. Let me show you a numerical. This one now. Okay. Numerical is a plane electromagnetic wave propagating in x direction. X means plus I cap. Is described by electric field is in y direction. Okay. Intensity of the wave is, so we have to find out intensity. Simple. Sir, intensity. I guess intensity equals to 1 divided by 2 epsilon naught E naught square multiplied by C. Yes, sir. So now, one second. So now, what I can write, it is 1 by 2. Epsilon naught is 8.85 10 to power minus 12 E naught. So now this is my E naught. 200 multiplied with 200 into C. What is C? 3 into 10 to the power 8. 8, 9, 10, 11, 12. 12 and 12 cancel out. So I have here 1, 2 and 1, 2 cancel out. So we can write 8.85 multiplied with 3 to the 6. 5 is 30. 56 is 59. So 9. We are doing something wrong, no? Look now. 3 to the 6. 30. 51. 46. So my answer is, I get this one. Option number second is my answer. Huh? Is my answer 53? Option number second. Okay. 53.1 watt per meter square is my answer. Easy? This is my answer. And I show you how we concluded this thing now. Okay, next numerical. Next numerical is a plane electromagnetic wave travels in vacuum along z direction. That is k cap. Okay. What can you say about the direction of its electric and magnetic field vectors? Okay. If it is going along z direction, it is go with z direction. So my electric field will be in x direction and my magnetic field will be in y direction. Done? On x or y, you can write this one also, right? Y and x. No issue. We don't need to be exact here. So if the frequency of the wave is 30 megahertz, what is its wavelength? We know c equals to nu times lambda. So we have to find out wavelength is lambda equals to c by frequency f. C is 3 into 10 to the power 8. Frequency is 50 and we're having mega. Oh, sorry, it is 30. It is 30 here. I will write here 30. 30, 10 to the power 6. 3 ones are 3, 3 ones are 3, cancel out. So we are having 10 to the power 8, then 10 to the power 7, which equals to 10 to the power 8 minus 7 equals to 10. So my answer came out to be 10 meter only. And 10 meter is my required answer. Easy, beta? Easy or super easy? Easy, no? No. Today the class will be somehow lengthier, no? You need to be in the class, okay? Because we will end the whole syllabus in this class. Okay, now this one now. A charged particle oscillates about its main position with frequency of this much. So frequency is given us. So we know that the source frequency is equals to EM wave frequency. Source frequency 10 to the power 9. So this is my EM wave frequency. EM wave frequency. EM wave frequency, right? Next one now. Question is, the amplitude of the magnetic field, that is B naught, of a harmonic electromagnetic in vacuum is B naught 510 nanotesla. Okay, what is the amplitude of electric field? Simple and very simple. How, sir? Because C equals to E naught by B naught. C is 3 into 10 to the power 8. We need to find out E naught. And what is B naught? B naught is 510 multiplied by 10 to the power minus 9. So I can write E naught is equals to 510 10 to the power minus 9 into 3 into 10 to the power 8. So I can write 511 only, 550, 11, 10 to the power minus 8 into 3, 10 to the power plus 8. Minus 8 plus 8 cancel out. It is 3 on the 3, 3 for the 15. It is 153 Newton per coulomb. Simple answer. Simple answer. Easy or super easy? Easy or super easy? Easy, no? Easy, right? You need to provide me your thoughts, no? How I am giving you the numerical. I guess numerical level is very good. These are your NCRT's numericals. And please just do your NCRT numerical also, okay? Next one. Okay. Suppose that the electric field amplitude of an electromagnetic wave is E naught, okay? And its frequency is V. Determine B naught. Okay, how to find B naught? How to find B naught? How to find B naught? Sir, B naught. Sir, B naught. How to find B? I will change the color now for a good thing. Okay, I will write this one now. B naught. C equals to E naught by B naught. I have to find B naught. So B naught is equals to E naught by C. What is E naught? E naught is 120. What is C? 3 10 to the power 8. 3 1 the 3, 3 4 the 12, 3 4 0. It will be 4 0 10 to the power minus 8. Or you can write here it is 4 10 to the power minus 7 Tesla. One is this much. Now next one. Next one. First one is this one. First one. Complete this B1 naught. Now second is omega. Omega. First of all, I guess omega is equal to 2 pi f. Yes, sir. 2 pi is 2 pi. What is f now? F is okay 50 megahertz. 50 megahertz. It is 100 10 to the power 2 plus 6 into pi. I can write 10 to the power 8 pi 10 to the power 8. So next one, this one. Now third one. Third one. K. What is K now? Sir, we know speed. Speed equals to omega by K. What is speed now? First of all, K equals to omega. What is omega? Omega is pi 10 to the power 8. Speed is 3 into 10 to the power 8. Cancel out. My answer came out to be pi by 3. My answer is pi by 3. Pi by 3. 4. 4. K. Lambda. Lambda. What is K now? K is 2 pi by lambda. K. Okay, lambda we don't know, no? K is K we have, now K we have. K we have, so lambda came out to be 2 pi by K. What is K now? K is pi by lambda, pi by 3. So I guess it is 6 only, 6 meters. 6 meters. Now we have to write, determine, find. So this one done. Find expression for E and B. So Y is equals to A sine omega t plus minus K times X. First of all, E equals to E naught. What is E naught? E naught is 120. 120 sine omega. What is omega here? Omega here. What is omega? It is pi 10 to the power 8. T is T plus minus K. What is K here? Pi by 3 into X. What is B equals to B naught? B naught is 4 into 10 to the power minus 7. It will be sine. Then same pi 10 to the power 8 T plus minus pi by 3 into X. My answer, simple. You can take some time also to get this thing in your mind. And I hope this thing is very easy, easily understandable. Okay. Okay. Now let's do one more topic. Topic is intensity due to a point source. My next topic is intensity due to a point source. Intensity due to a point source. Okay. Here, if here we are having a bulb, this thing is my bulb. So we will be drawing a spherical structure around a bulb. This bulb will be acting as a point source. And this bulb will be spreading its light in every possible direction. Okay, we know it. The bulb will spreading its light in every possible direction. We know it very well. Okay. So we will go to some x distance apart. We will go x distance apart here. Here. If this is my x or r distance apart. So here I need to find out its intensity. If the power of the bulb, if the power rated of the bulb is given as P, then first of all, what is intensity? Sir, intensity is energy per unit area per unit time. This is my intensity. Okay. So is it joule per meter square into second? Yes, sir. I can write it as a watt per meter square. What is watt? I can write it as an energy flux also. Energy flux. Okay. So watt is also power. Watt is a denote of power. Meter square is area. One more formula is there. Intensity. Intensity is equals to power per unit area. Power of the bulb is P and area is 4 pi r. It is r square. 4 pi r square. Done. So look, is it equal to intensity? What is intensity? 1 by 2 epsilon naught E naught square multiplied by C. Is it like this now? So what will be E now? So I can write, look now. I can write E naught square equals to P whole divided by 4 pi epsilon naught, 4 pi epsilon naught. Then I can write here C, here 2 C r square. So it will be 2 kp whole divided by cr square. So therefore my E naught electric field intensity will be equal to under root of 2 kp whole divided by cr square. This thing also you need to remember this formula. Intensity in terms of power. Okay. And we know that what is C? C is equal to 3 into 10 to the power 8 meter per second. And what is K? K is a constant 9 10 to the power 9. And we done this constant in my electrostatics. Easy or super easy? Easy, no? Again, these things are very easy and very you need to understand each and everything. Okay. Then we'll be having a chit chat about it. So let us just do some numericals. This one we are done. Next numerical. Okay. Next numerical is calculate the electric and magnetic field produced by a radiation coming from 100-watt bulb at a distance 3 meter. Assume, now what we have to find out? E naught, then B naught. How to find E naught? Sir, I guess E naught equals to 2 kp divided by r square multiplied by C. We know it. So now if we know it, so we have to do it. Okay. So look now. What is E naught? So E naught is 2 kp whole divided by c r square root. So 2 is 2. What is k? K is 9, 10 to the power 9. What is p? P is power. But here power is only 2.5%, right? So I can write 2.5% of 100 watt. So I can write 2.5 whole divided by 100 multiplied with by 100. So it came out to be 2.5 only. 2.5. So is it 2.5? 2.5 whole divided by C. C is 3 10 to the power 8. R is 3. It is 3 multiplied by 3. Then root 3, 3, 9. 9 and cancel out. So I can write here it is 5. 5 by 3 10 to the power 1. It will be 50 divided by 3 root. 50 would be 25 multiplied by 2 by 3 root. 25 is 5 square multiplied by 2 by 3 root. So my E naught came out to be, it is 5 under root of 2 by 3. E naught, what is B naught now? C equals to E naught now, B naught. So B naught equals to E naught. E naught is 5 under root of 3 by 2 by 3 whole divided by C. It is 3 10 to the power 8. I will write here 5 by 3, 2 by 3, 10 to the power minus 8. My answer. Easy? Easy or super easy? So I hope that you are getting something from my class, right? I am showing you the best numerical that you will find ever for your examinations. First of all, we are doing a topic. Then after that particular topic, we are getting some sort of application part of that formula. Let's suppose we now derived a formula how E naught equals to root 2 kp by CR square. And I am following the latest trend only. The latest. I am covering everything. I am not ignoring an iota thing in your syllabus. I am completing each and everything in your syllabus. Okay, but I am following latest NCRT only. Latest NCRT only. Okay. Next part. Next part is my electromagnetic spectrum. What is my next part? It is electromagnetic spectrum. That means we are dividing my electromagnetic wave. We are dividing electromagnetic wave in lot of different categories based on the usage of hours, right? So first category that you can see here. First category that you can see here, my first category is radio wave. Radio wave is the wavelength is more than 0.1 meter and it is produced a rapid acceleration and deceleration of electron in areas. Second part, microwave. Microwave wavelength is 0.1 meter to 1 millimeter. Klystron value or magnetron values. Okay. Infrared means it is 1 mm to 700 nanometer. Vibration of atoms and molecules. Light means visible region. It is 700 nanometer to 400 nanometer. You will find this thing in your NCERT. If you can open your NCERT, you will find this thing now. Electrons in atoms emit light when they move from one region to, that means uh, excited regions, right? From ground to the excited state. Then we are having ultraviolet, 400 nanometer to 1 nanometer. Inertial electrons in atom moving from one energy level to the lower energy levels. It will release UV rays. X-rays means 1 nanometer to 10 to the power minus 3 nanometer. X-ray tubes or inertial electrons, right? Gamma rays means less than 1 10 to the power minus 3 nanometer. Radioactive decays of the molecules or the nucleuses. Look, you need to study these things then, okay? Because if you are preparing for any examinations, so you have to prepare or you need to study some material. Numerical portions and the derivation and definition is numerical application, but I will show you now. But some subjective things you need to study, right? Radio waves, it is wavelength you need to find out, right? The wavelength, the electromagnetic spectrum goes from radio to gamma rays. My wavelength decreases, but my energy increases. Done? Next part, some sort of microwaves. So you can find here microwaves are also known as short waves, radio waves with frequency in the gigahertz range are produced by the special vacuum tube called klystrons, magnetrons, and gun diodes. Due to their short, you need to find it. No, it is for radar, speed guns, table tennis balls, right? So these are used in these things. No, some speed guns are being made in highways, not to detect which car is going fast and slow one. Their microwaves to be used. Okay, this one now. We are having a radio waves. Radio waves. Now we need to do it now. So radio waves, we know from the previous thing. This one now. Radio waves here. More than 0.1 mm. 1 m only, right? So 0.1 radio waves is which one? Highest one. It is 2, no? I guess 2 1 now. It is giving us wrong. It is highest here, 10 to the power 2 only. Then we are having microwaves. Okay? Microwaves is less than 0.2. That means 0.3. Okay, this one and this one now. Then infrared. Infrared is less than this one now. It is infrared is this one now. X-ray is lowest one. D is 1. So A2, A2, B3, B3, C4, D1. No. Third is correct. First is not correct. Third is correct. It was asked in NEET. Okay. Same one, you have to do it. The same one now. Okay. The infrared, gamma is the lowest one. So you have to find for gamma 1. Which is lowest one here? Lowest one. It is gamma, D is 1, D1, 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 D1. Or this could be possible and this could be possible, D1. Then we have an X more than gamma. It will be 4. 4. Yeah, option number 2 is correct. Option number 2 is correct. Next one now. The conditions under which a microwave oven heats up a food item containing water molecules most efficiently. Here, microwaves, the frequency of microwave and the frequency of the food items, they are resonating. Okay, when they are resonating, there will be a heating effect. Option number 3 is correct. The frequency of the microwave must match the resonant frequency of the water molecules. If they are doing so, there will be a heating effect. You will find it in the NCRT. Okay, the ultraviolet now. Okay, this is some numericals. It's a very easy one, no? They will ask you in the JEE, right? Okay, so we are having now Maxwell's equation in vacuum. We know that this one is Gauss's law. This one is my Gauss's law. I guess you are very well aware of the Gauss's law, right? What basically is Gauss's law? This one is my Gauss's law. Closure integration of E dot dA is this much. This is my Gauss's law in magnetism. Okay, if you are having something, let's suppose this is my magnetic field. If you are placing anything like that, look, incoming is equal to outgoing always. That means it is 0 always. Then it is my Faraday law. That is E equals to minus d phi by divided by dt. These are induced electric field, induced one. Then Ampere circuital law, right? Okay, now if E and key represents, if E and key represents electric field and AM vacuum, then magnetic field. Okay, so C equals to E naught by B naught. C equals to E naught by B naught. And one more thing, C equals to omega by K. Done. So that means E naught by B naught equals to omega by K. So we have to find out omega. So omega equals to 1 divided by one thing. It is K. Yeah, it will be, no, we don't need to find out omega, no? We don't have to find out omega. What do we need to find out? 1 second. We have to find out B. Yeah, B. So B is equals to 1 divided by omega. It will be K cross E. So only one option is there. Only one option is there which provides this one. Is option number E. Last numerical of our last numerical. Last numerical. We are having, look here, we are having two electric field intensity produced by a radiation coming from 100-watt bulb at a 3 centimeter. Okay, is E. Done. The electric field intensity produced by the radiation coming from 50 watt. Okay, we are having a 50-watt bulb. If we are having 100-watt bulb, 3 meter, it is E. Now we are having 50-watt bulb. How much energy it will be? E dash. Done. What is E? E equals to 2 kp whole divided by CR square root. 2 constant, K constant, C constant, R square constant. Okay, so that means E is proportional to the root of P. So I can write E1 divided by E2 equals to under root of P1 divided by P2. P1 is 100, P2 is 50 root. E1 is E only divided by E2 equals to 51 is 2, root 2. Therefore, my E2 came out to be E divided by root 2. This numerical from exemplar. Option number C. Option number C is correct one. Okay. Done. So by this thing, we can write here and part first of NCERT. We complete one book from NCERT. Okay. Now we will be starting modern physics. Modern physics. Then we'll be starting semiconductor. Then third one is optics. So only these three chapters are pending now. Modern physics, semiconductor, and optics. So then we will be saying bye bye to our syllabus. Okay. So then we will start our 11th physics. So my target is up to 15th. 15th of September I will end. Target, na? It will be plus minus 5 days. I hope that you enjoyed the session. You enjoyed my new sort of software, all these things, right? So if you have any issue or if you want to tell me anything, no, you can just ping me a message also. Done. Okay, I guess easy, na, super easy. So if you want to tell me anything, you're most welcome. You can go to the Telegram part. You can ping me a message there. Okay. Thank you, beta. Goodbye night. Good night. Good night. Bye. Thank you, beta. Bye. Good night.